Okay, so in today's video, I'm going to quickly discuss invariance and equivariance and their effect on convolutional neural networks in deep learning. I think this is a pretty fundamental concept in DL, so understanding it at a high level cannot harm you. So I'm going to use a few slides from a professor called Bernard Kainz. And first of all, to differentiate between invariance and equivariance, let's first talk about what the definitions say. So for invariance, it occurs when, if applying a function to a specific input, independent of any shifts in the input, the output is constant. So in this example of the cat, no matter where we move the cat on the image, it will still output cat if this was an image classification model. Notwithstanding, in shift equivariance, the change in input will commensurately be reflected in the change of output. That is to say, if we shift the input by a given measure, then the output will also be shifted proportionally. Okay? So that's the intuitive definition here. And in convolutional neural networks, we have one component that is shift invariant and one component that is shift equivariant, and these two combine to have a robust computer vision model. So let's see which of the two components. So I'm referring to the kernel first of all, and the pooling operation. So we'll start off with the shift equivariant operation, which is the kernel itself. So in this case, we have a convolutional neural network with three kernels represented by these three colors. And by applying the kernel, we can see that this is the superimposed output. And if you consider shifting the letter, or the number 3 rather, and then applying the same kernel, then we would equivalently have the letter 3 just a bit more to the right, for instance. And this means that it's shift equivariant, just as the example here on the right. And if we go to the second operation in the convolutional neural network, which is the pooling, so in this case we have a max pool operation, it's approximately shift invariant, or at least it's locally shift invariant. What I mean by this is that if we have, this is a 5x5 max pooling operation, if we shift the 5x5 window 1 or 2 pixels to the right, then on average, the max pixel will still remain within the window, and therefore independent of any shifts locally on the pooling operation, the max output is constant, just as the cat is constant in our toy example. So there you have the two aspects of the convolutional neural network, equivariant and shift equivariance and shift invariance. These are interesting topics, and there's also work done to prevent neural network hacks where scaling it by a certain amount will lead to the shift invariance breaking. So I'd encourage you to look at that. I'll leave a link in the description.